Welcome everyone. This is part 3 on our live stream series of creating a Nautobot plugin. Today we're going to be focused on creating our API views. So our create, retrieve, update, delete views on our specific model that we have already created. So to kind of recap where we're at right now, on Tuesday we went through, we set up our basic development environment for Nautobot, and we created just the base package for the Nautobot plugin IP range. And yesterday we stepped through, we created our base model, did some fundamental testing on our base model here. Our model is an IP range, so we have our start address, end address. We're giving the ability to associate it to a VRF, have a description that can be blank, and then a side field which is not editable. So we're not allowing a user to actually edit that field. We're dynamically doing that within the save function itself. So we are doing a size equals integer of IP address minus IP address, and that gives us our size. And what we caught a bug in on the initial writing last time was I wasn't counting the first IP in the set. So 3 minus 1 is 2. So that it only is counting for the stuff that's in between it. So we need to make sure that we're counting for the first item in the list as well. So 3 minus 1 plus 1 is going to be 3. So 1, 2, 3. I'm using that as an example because if we take a peek at our test cases, test case was 10001, 10003, and when we initially ran this without that plus 1, we got a failure. And one last thing, just to reiterate, the base setup that I am running Nginx that is performing reverse proxy with DNS records that are hosted inside of Route 53. The DNS and TLS termination with reverse proxy is not a requirement. I can go directly to the instance itself, but just because this is my own personal development environment, this is how I have it set up. So if we come here and we refresh, we'll see that we're good to go. And if we go into the admin panel, take a peek at our installed plugins, we're awesome there. And then if we come back here to API plugins, take a peek. Let's look at installed plugins. We have what our installed plugin is, and let me go back and take a look here at our init.py because I cannot remember exactly what we said. So we said IP range. Back over here, IP range, and what I'm expecting to happen is I'm not expecting to get an API root, I'm expecting to get a 404. Yep, so I don't have anything that's published inside the API just yet. So let's go ahead and let's build out some fun stuff within our API. So the first thing that we're going to be working on is creating our serializers. So before we can even create a serializers, we need to actually create a new folder inside of the package called API. And of course, I don't need a file, I need a folder. Go away. Thank you. Okay. Folder. API. And then inside of the API folder, let's go ahead and just add an init file. This is a file. This is a module. And then inside of there, let's add a serializers.py. And so within the serializers.py, we're going to need to pull in a couple different things. So we keep talking about inheriting from our base and getting a lot of moving parts and machinery without having to do any heavy lifting. So what we're going to be inheriting from base on this is going to be from Nautobot core.api.serializers, and we are going to import the validated model serializer. So this is going to give us a lot of extra moving parts and machinery, especially whenever we're looking at how it's automatically going to be publishing out. Sorry, I had a little bit of brain farts there, but how it's going to be automatically just publishing everything into the API itself. And we're not going to have to do a lot of heavy lifting. This is going to get a lot of bang for the buck. Because we're going to need to overwrite one of our fields because we're using a special type of field. We are going to need to, from REST framework, import serializers. And if we wanted to, we could actually do, because this is the only thing we are using from REST Framework serializers, we can actually do from REST Framework serializers import char field, just to kind of keep it a little bit cleaner and neater. And then we're going to import our models. So we can do from Nautobot plugin IP range, import models, or similar to how we did with REST Framework, since this is the only thing we're going to be pulling from models to be a little bit cleaner, we can import this specific model that we care about. So as we're looking at this and as we're getting started, there's one thing that I always love to do whenever I am creating an app within Django is I like to keep consistent naming. It allows me to very easily go from bits and places within the code itself and understand exactly what I'm working with, especially if I might have very similarly named items in multiple places within the code. So I feel to a certain extent, if we introspected the DSIM app within Nautobot, we'll see several models that are device role, device type, and we see all of these underlying models. And since they're similarly named, it could very easily, if we do abbreviations or do just kind of off the cuff naming of our subclasses, it can be very difficult to quickly trace things out and be able to just look at something and say, okay, this goes directly to this model without having to mouse over it and see where it's coming from or where it's being invoked or where it's being defined and where it's being invoked. And so this naming structure, and then you'll see this within Nautobot itself, is going to be the model name and then what we're doing with this subclass. And so since we are subclassing the validated model serializer, we're not going to do IP range validated model serializer, but it's a serializer. And so we're going to do IP range serializer so that we know that this is a serializer for the IP range model. Like I said, this name has nothing to do with the functionality. It could be foobar for all I care, but from an ease of use and an ease of navigation, it really does help a lot, especially when you're working with very large projects that may have very similarly named models that you're inheriting from. So let's go ahead and start by creating our serializer. So let's do our class. We'll call this IP range serializer. And we are going to subclass that from the validated model serializer. So out of the box from validated model serializer, if we come over, we take a peek at our model. I am cheating a little bit because I've worked with Nautobot a decent amount, but I know that the validated model serializer, with its moving parts machinery, I'm not going to have to specify what I'm caring about for the VRF for the model serializer. It's going to actually automatically just specify the UUID for the VRF. So if I wanted to go a little bit deeper or I wanted to nest it, I could do that. But if I just care about just seeing the UUID, I can leave it exactly how it is. I don't have to worry about trying to unnest it. It's going to know that the description is optional, and so it's going to know VRF and description are optional. And it's also going to know that description is a char field and that size, you can't actually try and edit size from the API, but it's going to give you the representation as a integer field. So for the start address and end address, what we're actually going to do, because we're using the var binary IP field, we're going to, like I said, I cheated. I've already worked on this previously, so I know the answer. Took me a little bit of troubleshooting, but we're going to specify our start address as a class level attribute, and we're going to assign that to a char field. And same thing with end address. We're going to specify this as a char field. So we have our start address, our end address. We're specifying this as char fields. Our description is going to automatically get pulled in using the validated model serializer. Our size and our VRF will also do the same. So next, what we're going to have to do is tell REST framework, which is behind the scenes, what is actually subclass to build the validated model serializer. We're going to have to tell REST framework which specific model that we are working with. And so we are working with the IP range model. So we can do a nested meta class and say model IP range And we're just going to say that we want to see all of the fields. So on the fields all, if we wanted to see just a subset, so if we just wanted to see display, why am I doing it like that? I just wanted to see a subset. I can't type. So let's say we just want to see display ID and VRF. So the display, because that's one of the things that we're going to be getting out of the box from the validated model serializer, will be the stringified version of it. The ID, which would be the UUID, and then for VRF, we would also get the UUID of the VRF. So if we did this as our serializer, we wouldn't be getting anything from the changelog. We wouldn't be getting anything from the tag from the tag objects. I think we actually need to add a tag information here. I have to go back and double check this after we get this up and going. And we're not going to get all the contextual information. So we're limiting the amount of fields that are coming back. And after we get everything up and going, I can come back to this and showcase what that would look like if we limited the fields. But for now, we're just going to say we're going to specify all fields. And so far, that's all we need from our model serializer. I'm sorry, from our validated model serializer for the IP range model. So let's go ahead and move on to the next item. Go to views.py. So similar pattern we're going to be inheriting from our core. And so we're going to be doing from nautobot.core.api.views import model view set. We're also going to make sure that we're importing our model and importing our serializer. So we can do from Nautobot plugin IP range.api. We'll do the same pattern since we're just dealing with one serializer. Import IP range serializer, and from Nautobot plugin models import IP range. And so we have our imports going. So the model view set serializer, let's go ahead and, I'm sorry, not serializer, the model view set, let's go ahead and take a peek at that. So if we come into Nautobot, go to core, go to API, go to views. We have a bulk delete, a bulk update model mixin, and then we've got our model view set, which is going to be subclassing from the bulk update model mixin, the bulk delete model mixin, and this model view set underscore. So what's this model view set underscore? So let's go look at our imports. I'm expecting to see somewhere, I'm probably running right past it. Yep, right here. So we see from REST framework. I don't need to do that. So we see from REST framework, we are importing the model view set as model view set underscore. So basically we are inheriting from REST framework and we're just renaming the specific item. So let's go take a peek at the core code for REST framework. So REST framework model view set. And I specifically GitHub, I don't care about. Go. Scroll down. All right. So we can see that we're inheriting from the model view set. And so the model view set is actually an amalgamation of a create model mixin, a retrieve model mixin, update model mixin, destroy this, and then the generic view set. And so essentially what we're doing here is giving us the ability to have all these underlying views that are built as part of these other view sets. And just by subclassing everything and bringing everything together into one model view set, we have our post operations. We have our get operators. We have our put and patch operators. We have our delete. And then we have another get operator, but for all objects instead of a single object. And then this is just the base view set that is creating everything for you. So cool. We got our model view set, got our serializer. So let's go through and start creating our view. So what did I just mention a minute ago? We are going to use the naming structure of model name and then what we are working with. So we are working with a view set and we are going to be subclassing the model view set here. Within the model view set, we're only going to set 2 class attributes, and we're going to see that with a very small amount of code because of the level of inheritance that we're pulling from and the amount of stuff that is automatically getting created by the upstream code that we're inheriting from. Where all we have to define is going to be our query set. Our query set is going to be iprange.objects.all, and then we need to specify our serializer class. And our serializer class is going to be iprange serializer. Cool. Save that. Off to the races. But we're not seeing anything restart. Let's cancel this out. Let's restart this. Maybe it didn't pick it up. Let's see what happens. Okay. We're off to the races. If I refresh here, do I get anything? I don't. I don't get anything yet because I haven't set up my URLs. I haven't told Django how to route the traffic for it. So let's go ahead and set up our URLs.py. So inside of API, we're going to set up a URLs.py, and we are going to create a order default router, which is going to be a subclass of the default router coming from REST framework. The default router is going to work in conjunction with the model view set and understanding all of the different methods that were implemented from that class level inheritance. So we do not have to go through and define a as view list, as view this, as view that, and point each individual URL pattern to that underlying view. It's just going to automatically figure everything out for us, and we're not going to have to worry about it. So what we're going to do is do from nautobot.core.api import order default router. And then we need to make sure that we import our views from our plugin. So from Nautobot plugin iprange.api, and since we're just dealing with one, we'll do the same pattern. .views import iprange view set. So now we need to create our router. So we'll do router, which this variable doesn't necessarily matter what we call it. We can call it foobar for all I care, but we're going to call it router. So we have our variable of router, which is an instance of the order default router object. And we're going to register our views. So register. And it's going to take in 2 positional arguments. The first positional argument is going to be the URL pattern. If we wanted to, and we can try this out in just a moment, I believe if I had just left this blank, I should actually just get this as our URL pattern. I don't believe I have to add anything to it, but we're going to start by just specifying IP range, because I know for sure that's going to work, but we'll try both of them. So the second positional item is going to be the underlying view set. So it's going to be the IP range view set. So what the default router is going to do is it's going to assign the list, the update, the retrieve, the delete, the get, all those underlying operators to these subclass functions that we're inheriting from. And it's going to register this URL pattern into Django so that we can be able to consume it. And the view name is going to be namespace based off of, if I remember correctly, it's going to be plugins-api, plugin name-api, then it's going to be model, and then whatever the operator is. But we can go through and use resolve to double check that in just a moment. So we got, and I believe it's going to be so model-list or model-get, if I remember, or detail, not get. Model list, model detail. Anyways, sidetrack. So we've got our router, we've registered the IP range as a URL pattern. This URL pattern would be API forward slash, API plugins, our plugin name. So not our plugin name, our plugin base URL coming from init.py, and then this specific URL pattern. So in this case, inside of our init.py, our base URL is IP range. So what I'm expecting it to be is API plugins. That's actually, I just realized I had that on installed plugins. IP range, which we don't see it, but API plugins IP range. So that's what that's the expected URL base, and then we're going to add IP range to the end of that. Clear as mud. So the last thing that we need to do is that we need to specify a URL patterns, and the URL patterns will be router.urls. And this is what Nautobot is going to be looking for whenever it's going through and doing its imports and registering its views into Nautobot. So let's go ahead and just to make sure that's going to be what our URL is. We're getting a 404 because Django did not register this on load time. So this was not a file that Django is tracking. So even though we're running in debug mode, because Django had no idea, or Nautobot had no idea about this file whenever it started up, it doesn't know to track it. So let's go ahead and Control-C, and let's start the service back up. We're good to go there. And then if we refresh, we now see that we have IP range as a view, and we also get a get, post, patch, put, delete, head, and options. And this is a very, very minimal set of code that we haven't had to try and invent the wheel or trying to understand any of this information. All of this is just magically done for us. And if we come back over to our serializer, and as I mentioned, if we wanted to, we could do display VRF and ID. We can save that. Since Nautobot knows to track that file, we see Nautobot automatically reloading this session. And if we come back over here and we refresh, it's a serializer, but it's not in the field options. Because that is a required field. You do have to at least have your required fields. You know, when you skip steps, you make mistakes. So let's go ahead and add our required fields, which are only two required fields are going to be start address and end address. Let's go ahead and save that. Watch it reload, and bang, we're there. So let's look at this again. So let me just comment that out. Do fields equal. They're all under. So we just got display, VRF, ID, start, end address. Then if I refresh it, we'll see we have the full payload. So awesome. This is really kind of cool. We're able to get all these kind of moving parts and machinery with a very small amount of code. Let's say we wanted to see a little bit more about that VRF. And so let's do from Nautobot dot, I think if I remember correctly, it's going to be in IPM.API dot nested serializers import nested VRF serializer. Cool. So right now what we're seeing is that the VRF is just going to be the UUID. We're not getting any additional information from it. It's just the UUID. It's just a pointer back to it. But let's say we actually wanted to get some exploded information back about the VRF that we are tied to it. So we can specify the VRF attribute. So we're going to tell the validated model view serializer that we want to see a different way of serializing the data for the VRF. And so to do that, we are going to add a VRF attribute on the class, and we are going to assign that VRF attribute to the nested VRF serializer. So let's go ahead and save that. Refresh. So now when we see the VRF, we can actually see the ID of the VRF. We have our URL pattern for it. We have our name, our route distinguisher, and then a display of that specific VRF. So we have the ability to see exactly what level of detail we care to see. And cool, we're off to the races. just for the sake of this, we're just going to comment that out, leave that there, but I'll leave it in the code so whenever I push it up to GitHub later, we have some examples and you can kind of see what I was doing. So this is really interesting. We've got an API with, this is 1, 2, 3, 4, 5, 6 lines of code if you exclude white space and imports. For the serializer, view was 3 lines of code, and URLs was 3 lines of code. So we're just over like a dozen lines of code, roughly. And we already have a fully functioning API based off of the model that we've already implemented. So we're not having to go through and build everything from scratch and blacksmith everything into all these very handcrafted, unique items. We're able to take advantage of all of the power of subclassing from the core models, which is subclass, and it's just extended. It's just an extension of Django REST framework, which is very, very powerful. But let's say, hey, I want to do some testing. I want to make sure that all of my fun stuff that I'm doing with my API is going to be exactly how I want it to be. We can do that. We can make that happen. So just because I like to have all of my tests kind of easily understandable and know exactly where they are, I'm just going to do a test API. Because I don't really care to have my API tested with my model and my model tested my API and my view tests or my UI views with my API. I like to kind of have some segregation between my tests, so I know exactly which file to go to. And especially as projects get a lot larger, it can be easier to maintain and know exactly where to go to find certain tests. All right, so let's go ahead and get this party started. We are going to do from nautobot.utilities.testing import API view test case. And then from Nautobot plugin IP range models import IP address. My goodness, trying to autocomplete for me when I don't want it to. Yep, and that's all that we're going to need from that standpoint. Kind of looking through, kind of thinking through my next step so I don't get ahead of myself. I do that a lot, but it's all good. I'll showcase it 2 ways. We can do that. And so for this, what we're going to need to do, if I remember correctly, we are going to create 3. Trying to think through this in my head. Could do this a little bit different on this one. Let's just wing it. Just like everything else I do in my life, I just wing it. So same type of pattern. We do IP range, API view test. And we're going to subclass from the API view test cases .API view test case. And so as you can see here, the nested classes within the API view test cases, we have a create, delete, get, list, and update. Since our view is actually the full CRUD operations, we can inherit from API view test case. If we were just doing specific ones as far as create, update, delete, if there are certain views that we only had read only, we could do just get and list and not have to do all the other destructive operators. So we will do the API view test case. And then we're going to add a couple of class level attributes. So we're going to do our model, and our model is going to be IP range. We're going to do some create data. And our create data is going to be a list. Stop auto-completing for me. I love it when things try to tell me how to live my life. So we can do a start address of one end address of 3 And just because I like being quick and easy, 10, 30, and then we're going to do a bulk update data. This bulk update data, we're gonna specify a specific JSON payload that we would be applying to all of the items, so we can do a bulk update. Bulk update data kind of makes sense. And the attribute that we're going to update is going to be description. And the description, we're just going to say test update description. Cool. What? Just because I like some little bitty Easter eggs, let's go ahead and save that. So I'm going to go ahead and grab another terminal session so I can leave that up and going. Do my export to make sure I got my environment variables there for me. Do a Nautobot server test. So if we remember back to whenever we were creating our model yesterday, that if we did just an implicit command at this level for the make migrations or the migrate, we're running that against the full code of Nautobot. So we're going to be introspecting and running all the tests from DSIM, from IPAM, from circuits, from everything that's in the core level of Nautobot. And running through all those tests, since we're not changing any of the upstream code, doesn't necessarily make sense. Also, I am not a huge fan of having to go through and wait a decent amount of time to run the tests. And so what we're going to do is just do Nautobot server test. I think we did this yesterday. Yeah, so we got our Nautobot plugin IP range, and we can go ahead and run our test. And I'm actually expecting at least one failure. And I'll get to that in just a second. There's something that we're not implementing, which is perfectly fine. All right, so there's another failure. That's what I thought. I couldn't remember if I needed let's leave it like that. That's fine. So I forgot about that. I needed to have 3 address, end address. Oh, you know what? This is fun. I'm kind of going out of order. Like I said, I had my local environment over to the right, and I didn't do exactly what I wanted to do. So I am skipping steps. So let's go back, and when you skip steps, you're going to make mistakes. So let's go back and let's fix the steps that I've missed. So we need to add a class method. So we're just going to do a decorator class method, and we'll do a def set up test data. Oh, that's fine. We don't necessarily need the super. And we're going to do IP range dot objects dot create and start as equals 2.168.8.0.0 and address equals 192.168.0.1, and this is where I needed 3 of these. I didn't have 3 of these before, so let's go ahead and let's just quickly do this. So we got bam, bam. All right. I'm expecting that this should now work for me. So let's go ahead and let's see if I get any more failures. So right now we ran 22 tests. We had 8 errors, 3 failures, and 1 skip. So let's see if we get better success this go around. So we got a lot better as far as our failures go. But we still didn't get exactly what we were expecting. So what we're seeing here is that we got a test list objects brief that is coming from the Nautobot plugin IP range test API, and then our specific test class. So what is this? So this is saying test list objects brief. What does test list objects brief mean? Well, what that means is that if we were working with the API and we passed in brief equals true, it would give us a brief representation. And actually, it didn't do anything. That's just because we changed the actual serializer. So it's not doing anything. But essentially, the brief it would show a brief version of the actual instances of the model. And because we are not implementing brief as part of this stream, we are just going to say def specify the specific test in this case. All it accepts in itself, and we're just going to pass. And in just a moment, we'll take a peek at the upstream code and we'll take a look at that. So now my expectation is that all of these things should pass. I should go from 22 tests ran, 1 failure, 1 skip, to 22 tests ran, 0 failures, 0 errors, and only 1 skipped. Technically, this test is going to run, but it doesn't do anything. It just passes. So there's no assertions, there's no errors, there's no syntax things that happen in invoking that specific test. It just doesn't bomb out. It just fails out as soon as it's invoked. It's technically counted as a test, but it's not actually doing anything. So it wouldn't count towards coverage or anything from that standpoint for this specific test. Man, I wish there was a way that we could speed up our tests. I wonder. Cool. So now we're at 22 tests, only 1 skipped. And you saw that it took a moment for us to be able to create the alias of the default database. And so that was actually the longest portion of doing the test. Actually running, once it created the alias and was able to run the test, it was done. It was easy. But it was that waiting period for us to actually create that alias, and that was the majority part of that wait time. So, like I said, we've already specified that we are doing the Nautobot plugin, so we can do tests, and we can do tests API. And so the test API is going to, what my expectation is that I'm actually going to drop down in the number of tests that I ran, because I'm specifying from the Nautobot plugin IP range test folder test API file. That's the test that I'm wanting to run, and I can have multiple test classes that are defined, and I can specify this specific test class. So if I wanted to, it doesn't really make any difference here, but I could specify the specific test class and run it. And so that, I mean, yeah, in theory, since that might save me a few seconds, might save me a little bit of time, but that's not really where I'm needing to shave the time off on this. Where would I shave the time off? Creating of the alias. So what we can do is we can do -- keep db. And so -- keep db, the first time you run it with -- keep db, it's going to create that it's going to create that alias if the alias doesn't exist, and it's going to use that alias. And so we can see we had that little bit of a delay, but now to do the same thing, it's going to be considerably faster. We're not having to wait as long. This value here in 0.316 seconds or 0.311 seconds, that's not counting the actual creation of that alias of the DB. That is just counting the actual execution of the test itself. So we can see that if we're running through and wanting to run through a lot of tests at once, we can specify it in that fashion. I just want to try something. I've not directly tried this before. I can't remember if I have to do dot notation or colon notation. Yep, you can do dot notation and it'll call the specific method itself. So if there's one specific test that's giving a lot of heck and you're really wanting to try and figure out what's going on, you don't really care to have to go through all of the tests to do it. So let's just add a underscore to the beginning of that so that it'll actually re-invoke the original test coming from the upstream. You'll see that we can very quickly run these and we can iterate on top of our tests and not have to wait for that database alias to be created every single time. Not have to wait for it to go through 300, 400, 500 tests before we get to the one specific test that we care about. We can very quickly and easily just run the specific items we care about if we're going through troubleshooting and attempting to try and work through some form of an issue. But we're going to set this back. Go ahead and save that. This should be back to passing. Now, what's going to happen if I keep DB off? So when we don't have keep DB on, the first thing it's going to do is it's going to try and create that alias for the database. Are we expecting it to bomb out? Are we expecting it for all of a sudden I have it blow up in my closet where my server's at? Or is it going to be able to run without any issues? Or is Django going to say something to me? Let's see. So as soon as we hit go, we see that there is already a test database alias that's been created, and it gives you the option that if you'd like to delete it, you can delete it, but if you don't want to delete it, it's going to cancel and you're not going to run your test. So let's go ahead and say yes. I actually wanted to delete it. I want to start over fresh because I wanted to do that. So we can see it's going to take some time to destroy the old test alias of the database. It's going to create a new one, and it's going to destroy it at the end as well. So now we went through the same exact process. We get the same outcome. And if we run it again, we'll see it's going to be creating that alias of the database again for us, running through the test, and then destroying the alias of the database. So you can easily see that there are efficiency gains that you can work through within your development cycle for writing test cases for your Django plugins, or not Django plugins, your Nautobot plugins. This specific thing, what I'm talking about with testing and how you can optimize that, this is core to Django itself, not necessarily from the optimization perspective. It's core to Django, not a Nautobot specific item. What the Nautobot specific item is the the API view test cases that we inherit from. So before we run away, let's see, where was I inheriting for that from? Nautobot utilities testing. So let's go take a peek at that. Nautobot utilities testing. API. So we have our API view test cases. And so inside of the API view test case, you can see it's tagged as unit test. We have our get objects, which has several different tests that are associated with it. We have our list and so on and so forth. You see all the way down. Then at the very bottom, we have this nested class called the API view test case, which is subclassing from those 5 nested classes that were already defined. And so this is just exposing a way for us to quickly and easily get all of the tests together in one large class, but still give people the ability to where that if you just wanted to do get operators, you can do get and list if you wanted to subclass from that. Or if you only needed update for whatever reason, you had something very specific, you wanted a separate test class that you were just testing update, you can inherit from that, and you can run those just by themselves and not have to run the whole slew. But that's kind of showing some of the moving parts of machinery. And if you wanted to demystify what's going on in the back end and why a certain test is failing from this inherited testing framework that was developed, you can very quickly and easily take a look at that. So let's come over here. So we're going to be adding permissions, we're doing a URL, a response client, and the only thing that we can see here is that we have a brief equals 1. And so it's just going to be validating the actual fields that are coming out are going to be from the brief fields. So essentially, very quickly and easy way of saying we've got the ability to minify the amount of data that we're passing back in our JSON payload. But like I mentioned, we're not actually taking advantage of the list objects brief within this. So testing for it doesn't make sense. So we're just going to pass on it. If I wanted to not pass on it, I believe, I may be wrong on this, but let's go ahead and save that. Let's run this again. I can set a class level attribute of basically all of the fields. So it would be testing, but it would be testing with saying everything's going to be there. And I'm just being lazy to quickly grab that. I believe it's going to be brief fields is what it's called. Now my expectation is I'm expecting this to pass this go around. Yep, so I could either tell it to pass and not actually test that, but because I'm not specifying brief fields, but if I wanted to actually test it and make sure it's working correctly, I just specify the brief field attribute on the class level, and I'm able to test against it. But like I said, there's not any value to testing this since I have not implemented this functionality. So in my personal opinion, I don't like doing that. I don't have that functionality implemented. I'd rather just be a little bit less cryptic and say we're passing on it. If I wanted to be a super good steward, I can say functionality implemented has to not test. So something simple as a little pointer, so if anyone came behind me, they can see the reason why I'm passing on that specific test case. Just because I like running the test over and over and over again and seeing all my passing tests. Just run it one last time. Here, let's run all of my tests. 22 tests passed, or 22 tests ran, 21 tests technically passed, but if we want to get real, it's 20 tests passed, and one was an implicit pass, and then the last one was skipped. So cool. On that note, I believe we've covered everything that was planned on being covered today for the API view sets. It's been a pleasure, everyone. I'll catch y'all tomorrow, same bat time, same bat place, and we're going to be covering the UI views. So we're going to create some UI views specifically for the model that we've created. Thank you, everyone, and have a